In this lesson, we will look at the various ice and rain protection systems available for aircraft windscreens. Windscreens are protected from icing by fluid sprays or by electrical heating. Cabin air may also be blown across them for demisting. Wipers and washers are also provided. And on some aircraft, these may be assisted by the use of rain repellent systems. We will now look at these systems in more detail. Independent two-speed wipers are usually provided for the pilots. They may be electrically or hydraulically powered and are controlled by switches on the flight deck. They normally have a parking facility. When the switch is placed to off, the wipers will park at the bottom of the screen. Windscreen wipers should not be operated on a dry windscreen. The windscreen washer system sprays washer fluid onto the windscreen panels and is used in conjunction with the wipers to clean the windscreens. A typical system consists of a fluid reservoir, an electrically driven pump, and pipes feeding the fluid to spray jets below the windscreens. A single washer button controls the fluid for both screens. There are two types of rain repellent system in common use. In one, the windscreen is given a permanent hydrophobic or water repellent coating during manufacture, which causes the water to form large beads and roll off the surface. In the other, a temporary fluid coating is applied to the screen when required. Rain repellent fluid should only be applied to the screen during very heavy rain. In a typical fluid rain repellent system, there will be a nozzle for each screen and a manifold which stores and distributes the fluid to the nozzles. The manifold is charged with repellent fluid from an aerosol-type disposable container which screws into it. Electrical time-controlled solenoid valves control the flow of fluid to the nozzles. Rain repellent fluid is sprayed onto the respective windscreen by momentarily pressing the rain repellent button switch on the captain's or first officer's wiper control panel. Each actuation of the switch opens the valve for a preset period of time, regardless of how long the switch is held in. The repellent reacts with the water, increasing the size of the water drops, which are then blown off the screen by the airflow. Depending on airspeed and rain intensity, each actuation should be adequate for 2 to 5 minutes of repellent action. Rain repellent fluid must not be applied to a dry windscreen, as it will reduce visibility. The method employed in a fluid windscreen de-icing system is to spray the windscreen panel with a methyl alcohol-based fluid, which will melt any ice that has formed. The principal components of the system are a fluid reservoir, a pump, which may be a hand-operated or electrically operated type, supply pipelines, and a spray tube unit. Here, we show a typical aircraft system in which fluid is supplied to the spray tubes by an electrically operated pump. Electrical windscreen heating systems are almost always anti-icing systems. Windscreen heat is used from takeoff until landing because the heat increases the flexibility of the screen and hence its resistance to damage from bird strikes. A heated windscreen is of a laminated construction. In the typical example shown here, the film-type resistance element is sandwiched between a hard glass outer coating and a thick clear vinyl panel or interlayer. There is another hard glass panel on the inside of the screen. There are two types of electrical windscreen heating systems in common use. One system has a temperature sensor attached to the windscreen, and the other has a temperature-sensitive switch. Both are controlled and monitored by cockpit switches and warning lights. In both types of system, the resistance element is heated by alternating current or AC supplied from the aircraft's electrical system. The power required for heating varies according to the size of the panel and the heat required to suit the operating conditions. Air from the air conditioning system can be blown across the inside of the screen for demisting purposes. In the system using a temperature sensor in the windscreen, the sensor sends temperature signals to an electronic controller. The controller varies the current flow to the windscreen to maintain it at a constant temperature. This is typically around 30 degrees Celsius in flight, and a lower temperature, typically 16 degrees, on the ground. The changeover is made by the landing gear air-ground logic system. This system has the advantage of keeping the thermal gradient or temperature difference between the inside and outside of the screen to minimum, thus increasing the useful life of the screen. In the other system, temperature-sensitive switches or thermostats are fixed to the windscreen. When the screen reaches the required temperature, the thermostat opens, switching off power to the screen. When the screen cools again, the thermostat closes, reapplying power. In addition to the normal temperature control circuit, this type of system usually has incorporated in it a circuit which supplies more heating power under severe icing conditions when heat losses are high. When the higher power setting is selected, the supply is switched to a higher voltage output, thus maintaining the normal operating temperature. Both systems also have a thermostat in the windscreen for overheat protection. If the normal system fails to control the windscreen temperature, the overheat thermostat will cut off the power and put on a warning light. On some systems, the system will now operate in the overheat mode, with the overheat thermostat controlling the temperature and the warning light cycling on and off. On others, once the overheat thermostat opens, the warning light is locked on and heat can only be reapplied by cycling the control switch to off and then back to on. If the windscreen should overheat, then it may suffer permanent damage to the vinyl interlay. This will manifest itself as vinyl bubbling and discoloration. That is the end of the lesson. You have learned that windscreens can be protected from icing by fluid sprays or by electrical heating. Remember that electric heating of windscreens increases their impact resistance, so it is kept switched on from takeoff until landing. Remember also that cabin air may be blown across the windscreens for demisting purposes. You now know that wipers are used to clear rain from the screen. Remember that they should not be used on a dry windscreen. On some aircraft, the wipers may be assisted by the use of rain repellent systems. Bear in mind that rain repellent fluid should only be used in very heavy rain, and that it must not be used on a dry windscreen.